already did the A part, B part, C part in my previous videos. The D part of the question is asking repeat B for VCM is equal to negative 0.1 voltage. And in the B part, if you look at the things we had to find out is we had to find out the VS, we had to find out ID1, ID2, VD1 and VD2. VS is basically the voltage right here, that is equal to VCM minus VGS. That equation is already given. But if the equation is not provided, you can still find it because the VCM is right here. That is the common mode voltage. That is right here. And gate source is the next one. So this one minus this one should be equal to this one. So from that you can derive the equation. But the equation is already there. So we can just apply that and find the VS value. We are doing the D part. Let's look at it. D part, we are finding the VS, that is equal to VCM minus VGS, and the VCM provided to this question is negative 0.1, so substitute that. And the VGS I did in my A part of the question. I did it in my previous video. You can, if you want to know how did I do it, you can watch that video. But I found the value to be 0.6. So minus 0.6, so that one gives us negative 0.7 voltage. That is VS. And then we have to find out the ID1 and ID2. Okay, ID1 is basically whatever the current flowing through the train, and the train current flowing is mentioned right here, that is I divided by 2, and the I value is already provided, that is 0.16, so we can just put that on right here, I divided by 2. And then I is 0.16 milliampere divided by 2, that is 0.08 milliampere. And ID1 is this, and ID2 is equal. The reason is there are two ways you can find it. Like you can just look at this W over L ratio, that is equal for 1 and 2. It means these two MOSFETs are matched. If it matched and are aligned like this, it means this is a current mirror. Whatever the current flow through this is exactly same current flow through this as well if it's matched. So from that you can say this one is equal to this, or you can see they also mentioned that this also I divided by 2, this one also I divided by 2. So if you calculate also you will end up getting this. So you can say ID1 is equal to ID2, therefore ID2 also equal to 0.08 milliampere. And now we have found out VS, ID1, ID2, and the next one is VD1. VD1 is the voltage after this resistor. You can form the equation. The equation is already there, VDD minus I divided by 2 RD. And if you wonder how the equation derived, you can form the equation for the current equation, like whatever the current, like let's say this current is ID. This current must be equal to this voltage VDD minus VD1 divided by the resistor in between, that's RD. So ID is equal to VDD minus VD1 divided by RD, and if you rearrange this one in terms of VD1, you end up getting this. So since the equation is already there, I just go ahead and substitute. Let's put that one over here. VD1 is equal to VDD minus I divided by 2 times RD, and VDD is provided in the question, that is 1 voltage, so put that one right here. And then minus I divided by 2, that's the one we calculated for ID1, that's 0.08 milliampere, so plug that one, 0.08 milli. And the resistance also provided, that is 5k ohm resistance, so put that one in, 5k, and if we calculate this one we will end up getting 0.6 voltage. And if you look at for VD2 is exactly same as VD1 because the resistance is equal, the current is equal, the VDD value is equal, so the VD1 must be equal to VD2. So we can say VD1 is equal to VD2, therefore VD2 also equal to 0.6 voltage. And that's it for this question. I hope you guys found it helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.